Alright, our next unit is all about algebraic equations. In our last unit, we talked a little bit about algebraic expressions, which was basically taking fractions, so they had a numerator and a denominator, where either the numerator, denominator, or both were polynomials, so they had variables in them. Well, now we're going to look at the same kinds of things, only we will have the equals in between them. So something like this, where we have two algebraic expressions set equal to each other. Now, anytime where you see one where it is one algebraic expression equals another, so it's just fraction equals fraction, we can always use our cross multiplying like this to find our answer. So in a example like this, when we cross multiply, remember, just like in our last unit, this whole piece, x minus 5, is considered one big term, or one big factor. Same with this x plus 4. Whenever there is a add or subtract with your terms in a numerator or denominator, the whole piece works together. So when we multiply these, or cross multiply these, it's going to look something like this. X minus 5 times x plus 4 equals 5 times 2. This whole piece times this whole piece equals this one times this one. We just cross multiplied right across those two. Now is the point where we have to do our foiling. So x times x times 4, negative 5 times x, negative 5 times 4. When we do that, it's going to look something like this. X times x is x squared, x times 4 is 4x, negative 5 times x is negative 5x, and negative 5 times 4 is negative 20. And then 5 times 2 is, of course, simply 10. So now what we want to do is combine any like terms. We have positive 4x and negative 5x. This one does not combine. This is an x squared. So x squared is different from x terms. So only these two will combine and make a negative 1x. And to get rid of the 10 on this side, we will simply subtract it, because we want this side to be set equal to 0. So now we've got x squared minus 1x equals 30. From this point then, we want to factor this out. So we use our AC factoring. There's a 1 out here. 1 times negative 30 is negative 30. If we break negative 30 into two things that would add up to negative 1, that would be negative 6 and positive 5. These two will add up to, negative 1, multiply to negative 30. Now from here, x squared minus 6x plus 5x minus 30, we can start factoring. Take x out of both of these, take 5 out of both of these. Notice x minus 6 and x minus 6 happens both times, so there's an x minus 6 and an x plus 5. Now, this is what's called the zero product property. When we've got two factors, this red one and this green one, that means these are being multiplied together. This whole number and this whole number being multiplied to make 0. Remember, the only things, or the only time when we can have two numbers being multiplied to make 0 is if one of those numbers is 0. How would we make this whole factor, x minus 6, equal to 0? Well, x would have to be 6. If we plugged in 6, 6 minus 6 is 0. 6 right here. 6 plus 5 is 11. 0 times 11 would be 0. So 6 is going to be one of our answers. Let's look at this factor, though. How do we make this one 0? Well, that would have to be a negative 5. If we plugged in negative 5 over here, negative 5 minus 6 is going to be negative 11. Negative 5 plus 5 is going to be 0. So negative 11 times 0 would also be 0. So these are going to be our two answers. X equals 6 or negative 5. Okay, and again, that's how you would solve it if they are just one fraction equal to another. You cross multiply. When we just have rational expressions, it's a different procedure because they're not equal. This is just a review of our last unit. If we want to simplify this, we need to find our common denominator. So on this side we have a 5 and we have a y. On this side we have a 5 and we have an x. So we need to ask ourselves, what are we missing from both sides? Well, they both have 5 already. This side has a y, so this side needs a y. This side has an x, so this side needs an x. Which means I'm multiplying top and bottom by x over here. I'm multiplying top and bottom by y over here. Again, because this is x plus 3y, I have to think of that whole thing as being multiplied by y, so it's going to have to distribute. When we do that, it'll look something like this: 5x squared over 5xy plus y times this whole piece, x plus 3y, over 5xy. Now notice these are common denominators. Common denominators we can combine. We'll distribute this out real quick. Y times x is xy. Y times 3y is 3y squared. Again, they already have the common denominator, so we just plug everything together. 5x squared plus xy plus 3y squared. This whole thing would be our final answer then. At this point, we check this, this, and this. Can we take anything out of each of those pieces? Is there a number or a variable that we can take out of there? In this case, there is not. There's not going to be anything that we can take out of there, which means there's not anything we can cancel out of top and bottom, so this is our final simplified answer. Again, that should be review from last unit. Using those ideas, though, this is how we are going to work with rational equations. Now again, this is just an equation with fractions on both sides, and one side also contains adding or subtracting with the fractions. So here we can see we've got two rational expressions being added, and it's all set equal to another rational expression over here. To solve this, our process is factor the denominators if necessary. Using your factors, determine the least common denominator. Determine any restrictions on the variable. So again, that just means what are our excluded values? What value for the variable would make our denominators 0? Because we can't do divide by 0. After that, we want to get a common denominator for all of our terms. Then, since we'll have a common denominator on each piece, we can essentially just kind of ignore it. All of them are the same anyway, so we don't really need to worry about them anymore. All we're doing is just adding or subtracting all the numerators together. Then we will solve the equation for the variable. At the end, we're going to double check and make sure that our answers are possible. Okay, and that goes back to step 3 after we determine any restrictions. So let's start right away factoring the denominators if necessary. We've got 2n, 2n, and n, which means these two over here are the same exact thing. There's a 2 and there's an n. This one just has n. So what is everything missing so that they would have the exact same denominators? Well, these two over here already have this n. So these won't need anything extra. This one does need something extra. It needs that 2. It's missing the 2 from over here, which means I have to multiply the top and the bottom by 2. When I do that, this denominator becomes 2n, which is the same as these denominators, which means we no longer need to worry about that denominator. We can essentially cross it out and ignore it. Before we do that, though, leave that there, we're going to determine any restrictions. Because all of these are 2n, 2n, and n, and we cannot have a denominator set equal to 0, we need to think, what are the possible values of n that would make a denominator 0? The only thing that would work for that is if n were equal to 0, because 2 times 0 is 0, 2 times 0 is 0, 0 alone is just 0, so that means n cannot be 0. This is our restriction. We'll keep that in mind, or kind of write it off on the side to remind ourselves that we cannot have n equaling 0. From here, again, we get rid of these denominators. We won't be needing them anymore. And we're just going to solve the equation that's left over. We have an n minus 4 plus 3 on one side. That's going to equal 1 times 2. Well, what is 1 times 2? It's just simply 2. So our equation right now says n minus 4 plus 3 equals 2. Combine like terms on this side, we get n minus 1 equals 2. How do we get n alone now? Add 1 to both sides. Add 1, add 1. What is going to be our final solution then? N equals 3. So at this point, we were at step 6. We've solved the equation for the variable, n equal 3. Step 7, we need to make sure to check the answer, make sure that all of our answers are possible given our restrictions. Our answer says that n equals 3, and that'll make this work. Our restrictions say that n cannot be 0, which means that this one will work. This is okay to have n equaling 3. That is going to be our solution. Let's look at another example. We've got 1 over 6k minus 1 over k squared equals 5 over 3k. So, first we're going to factor the denominators if necessary. We're going to look at each piece. This one is 6k. 6 is actually 2 times 3, and it's being multiplied by k. K squared is k times k, and 3k is 3 times k. So it looks like each piece is actually missing something. Because this middle one has 2 k's, we need to make sure all of them have 2 k's. So multiply a k to this one, multiply a k to this one. Okay, now we're going to need to look at this middle one. This is missing 2 and 3. You can think of it as it's missing, that's 6. So we need to make sure this one has a 6. This one is also missing 6. It has 3, it's just missing this extra piece 2. So we need to multiply 2 to this one. When we do that, when we multiply k to this one, 6 to this one, and 2k to this one, they will all have a common denominator. Once they have the common denominator, we can cross it out and ignore it. Okay? So in a sense, our least common denominator, that LCD that we found, is going to be 6k squared. 6 times k, or 2 times 3 times k times k. It will be 6k squared in the end as our LCD. Now we need to determine any restrictions on the variable. What value of k would make our denominator 0? So we're thinking k squared equals 0, or 3k equals 0, or 6k equals 0. Well, if k squared equals 0, what would k have to be? 0. So that's at least one of our excluded values. How about 3k equals 0? Again, that would make k equal to 0, so we can't have k being 0. What about 6k equals 0? Again, k would have to be 0. So our only restricted value is k cannot equal 0. At this point then, we go back to all of our numerators. Once we multiplied this side by k, so right here we're going to multiply a k. This one we need to multiply by a 6, so we're going to put a multiply there. This one we need to multiply by 2k. Since we're multiplying our numerator and denominator by the same thing, and all of these denominators are going to become the same, we can cross them out and ignore them. We no longer need the denominators. So, that's step 5, get rid of all the denominators once they're the same, solve the equation for the variable. This is going to be the equation we've got left. K times 1 is just k, minus 1 times 6 is 6, equals, right here, 5 times 2k makes 10k. So this is going to be the equation we're working from. From here, solving it on both sides, we are going to subtract k on both sides of this. What that means is we're subtracting 1k. So 10k minus 1k means what we've got left over is a negative 6 equals 9k. How do we get k alone then? We need to divide by 9 on both sides. Divide by 9, divide by 9. And we now have negative 6/9 equals k. We can actually reduce this though. 6 over 9 is the same as 2 over 3. So our final answer should say negative 2/3 equals k. Step number 7 though means we need to check and make sure that our answers work, that they are possible and they are not a restricted variable. So we have negative 2/3 equals k. It says that k cannot equal 0. Well, this isn't 0, so this one does work. That is how we would solve for k in this rational equation. All right, let's look at a few more examples. We always start by looking at our denominators. Here we've got x. Anytime you've got just a whole number like 1, you can always call it that number over 1. So we've got x, we've got 1, and we've got x. So it looks like what we're missing, or what our common denominator would be an x. Because this one we can get x, this one we can get to an x, but it's not there yet. This one we can get to x. So we need to multiply this by x on top and on bottom. When we do that, we now have a common denominator, so we can get rid of all of these denominators of x. Before we do that, we just check and make sure what is the only value that x cannot be. X cannot equal 0. That's our restricted excluded value. Now we just look at the equation that's left. 5 plus x equals 1. Subtract 5 from both sides and we get x equals negative 4. So that's going to be our final answer. We check. X can't be 0. X is negative 4. This works. So that's going to be our answer for that example. All right, so now we've got an example with some a little more complex denominators here. Here we've got an a minus 6. Here we've got a squared minus 6a. Here we've got a squared minus 6a. We want to factor each one of these as best as we can. Factoring this first one, we have an a minus 6 in parentheses. This whole thing is our factor that we can take out. We can't simplify this anymore. Because it's a minus or a plus in between here, this whole thing is considered the factor. Now for this one, this a squared minus 6a is considered the factor, but we can take a out of both of these. So we'll pull an a out, a times a minus 6. This one actually has two factors, the a and the a minus 6. This one over here is the same exact thing. A squared minus 6a, we can pull the a out, and we have an a minus 6 left over, which means this a minus 6 is already found on these two. There's an a minus 6 and an a minus 6 already in here. So the only thing we need to change is this one needs to be multiplied by a. That way it'll be the same as these two. So we multiply a on bottom, multiply a on top, and now we double check and make sure we don't have any excluded values. Here we've got two factors, a and a minus 6. Now what would make that denominator 0 then? Well, if we had this factor equal to 0, that means a cannot be 0. Because if a were 0, we'd have 0 times negative 6, which would be 0. And we can't have a 0 in our denominator. So we know a can't be 0. Is there anything else a can't be? Well, let's look at this one. A minus 6. If that one were 0, a would have to be a positive 6. Because 6 minus 6 is 0. So a cannot be a 0 or a positive 6. Those are going to be our two restricted answers. Now we go back and look at our values. Common denominators we can cancel out. And we're left with just the equation now. A times 1 is just going to be a plus 6 equals 1. This is the equation we need to solve. Subtract 6 from both sides and we get a equals negative 5. As of right now, we pretend or we think that this is going to be our final answer. We just have to double check it with our restricted values. A can't be 0 or positive 6. Right now we have a is negative 5, so this one checks out just fine. Let's look at another example. Again, we have a whole number 1, so we think of it as 1 over 1. Now we look at our three different denominators. We have a p squared, a 1, and a p squared. These two are the exact same, and they mean p times p. This one over here, just simply 1, which means, since it's 1, in a sense, these already have that factor 1. These aren't missing anything. What is this missing? P squared, or p times p. So we need to multiply the top and bottom of this one by p squared. Okay, before we can do anything else, we need to look at these, our three denominators now, our common denominator, and check for any extraneous solutions. So again, the excluded values. What can p not equal? If it's p squared on each of them, we'd say p squared can't be 0, which means we can't have p equaling 0. That would make our denominator 0, and we can't do that. So now that we have p squared on all three of our denominators, we can cancel it out, and we're just left with 1 over here equals 1 times p squared is p squared plus p minus 1. This is now the equation we need to solve. Because we have a p squared, we're going to want to get it set equal to 0 so we can factor it, just like our very first one. Subtract 1 from both sides and we get 0 equals p squared plus p minus 2. From here, we think 1 times negative 2, a times c, is going to be negative 2. What are the factors of negative 2 that would add up to this positive 1? Well, we'd have a positive 2 and a negative 1. So this is how we break it up into 4 pieces. Factor by grouping this group and this group. We can take a p out of these two, and it leaves p plus 2. We can take negative 1 out of these two, and it leaves p plus 2. So our factors are going to be p plus 2 and p minus 1. If 0 equals p plus 2, I'm going to underline that one in red, and p minus 1, I'll underline that one in green. We've got this red piece times this green piece equaling 0, which means one of them has to equal 0. How would we have p plus 2 equal to 0? Well, p would have to be negative 2. How would we have p minus 1 equal to 0? P would have to be positive 1. So these are going to be our two solutions. Either p has to be negative 2 or p has to be positive 1. We need to go back and check, though. P cannot equal 0, and in neither of this case does it do that. So this would be our end solution. We've got another example here. 1 plus 4x plus 20 all over x equals x squared plus 3x minus 4 all over x squared. Here we've got 3 different denominators. We have x times x, which is x squared. We have an x. And remember, if it's just a whole number, we can put it over 1. So we have a 1 here. We need to think, what is each piece missing? This already has x and x. So this one is just missing an x. We need to do times x and times x up here. This one is missing x squared, so we times x squared on top and on bottom. We also need to check for extraneous solutions. If we have x and x squared and 1, what can x not equal? X cannot equal 0. That would make these two denominators be 0, and we cannot have that. So this is our excluded value. Now we simply FOIL this out or distribute everything out and use that as our equation. Now remember, because this is 4x plus 20, we have to consider it all one piece. So when we do x times that, it's x times 4x and x times 20. That's going to make our equation then x squared times 1 is x squared, x times 4x is 4x squared, x times 20 is 20x, equals x squared plus 3x minus 4. On this side, we can combine like terms, and we get 5x squared plus 20x equals x squared plus 3x minus 4. From here, we can start getting rid of a couple different pieces at a time. If we subtract 1x squared from both sides, minus 1x squared, that'll help get rid of this piece. We can subtract 3x, that'll get rid of this one, and then we will add 4 to both sides. Add 4, add 4. When we do that, we are left with 4x squared plus 17x plus 4 equals 0. We've set the whole thing equal to 0, so now we can factor it and use our zero product property. AC, 4 times 4 is 16. What are the factors of 16 that will add up to 17? Well, that'd be 16 and 1, so 16x and 1x. Now we can factor by grouping. Here's a group, here's a group. What can we take out of each piece? 4x comes on the outside of this one, it leaves x plus 4. 1 can come out of this one, it leaves x plus 4, which means our two factors are x plus 4 and 4x plus 1. Now this one is probably easy to see. X just can't be, or x would be negative 4, because negative 4 plus 4 makes 0. How would we make this one equal to 0 though, if it's a 4x plus 1? Well, we have to set everything equal to 0 to do that. 4x plus 1 equals 0. Minus 1 on both sides gives us 4x equals negative 1. Divide by 4 on each side and we get x equals negative 1/4. So x would either be -4 or it could be -1/4. As of right now, these are our two solutions. We double check with our excluded value where it says x cannot be 0. Neither of these are 0, so these both check out. And that would be how to solve our rational equations.